Hello everyone, welcome to VLSI Toolbox channel. Today I will be talking about logical equivalence check using a Cadence Conformal tool. That is how to do logical equivalence check using Cadence Conformal tool. So before going to the discussion, let's check where we are in the digital IC design flow. We are in the post synthesis verification steps. That is, after synthesis, whether my netlist is altered or not, whether my logic is altered or not, that should be verified. For that, we have to do the verification. This can be done in two ways. One is functional verification, and that is LEC. So in functional verification, we generally have to write all the test cases in terms of test bench and simulate it and verify the waveform. So it is very much tedious to do and difficult to achieve all the test possible cases. So the design engineer will prefer LEC check, logical equivalence check, which is faster and easy to carry forward. So why LEC? As I have already told, in comparison to functional verification, LEC takes less time to compare the netlist. So during LEC, it requires two files. One is golden netlist, that is your RTL code, RTL logic, and another is a revised netlist, that is the synthesized netlist with some scan inputs or scan logics inserted for DFT, for doing DFT. So let's say the golden netlist have a function y equal to f of a, b and c, and in revised netlist, say y dash is the revised netlist, and with f of a, b, c, we have inserted some extra logic for debugging g of a, b and c. So in LEC, we generally make g of a, b, c to 0 with some constant, so that we can compare y to y dash. So this is the process of conformal tool to make the scanned circuit or for circuit which are inserted for testing the circuit or logic to 0 and compare the original netlist with this revised netlist. So let us explain it with some example. Suppose this is a golden netlist where you can see the output is the output of flip-flops. 4 flip-flops are given to a combinational logic, and the output of combinational logic is fed to another flip-flop. So it is very much tedious to write all the logic of flip-flop and test the flip-flops. So we can test a part of this, that is a combinational logic. We can make a test circuit and check this combinational logic whether it is performing or not. So for that, let us take the combinational logic as a function d as the output. You can see d is the output here, d is the output here, d is a function of q1, q2, it is obvious. So in the revised netlist, we will insert this type of circuit where d will be the input of 2:1 mux for scanning this flip-flop, and flip-flop is instantiated in as ff underscore 1. But here you can see SI scan input and scan enable and extra pins are there. We will set in LEC SI equals to SC equals to 0 to nullify the extra circuit and make it suitable for comparing y equals to y dash. So this is the process of doing LEC. In LEC, we generally require a post synthesis verification file, that is do file. So here in this case, one thing you can note that combination logic is fed by a output of some flip-flops, and the combination logic output is again fed to a flip-flop. So this process, this may form one cone, you can see here. So in the LEC language, it is a logical cone, and these 4 flip-flops are the support point of this logical cone. So this is the process of LEC, and the blocks which is not mapped or which is not scanned are named as PO, primary output, primary input, and black box, latches. Actually, it tries all the flip flops, all the points mapped, try to map all the points, scan all the point, but whichever points is not touched, it make as a black box or primary input, primary input in the LEC. So for testing the for the simplicity of testing, it makes the blocks as this as it names this block as primary output, primary input, black box, and latches. So this is the process of LEC. So before going to the tool, let us check the synthesize file again, synthesize script file again, and see the commands. Let us understand some commands here so that it may be very much useful to understand it. So this is the some commands of part command of tickle file of genus tool, which I have already shown in my part 1 video of this series. So here you can see I have here you can see synthesize to generic effort. This one, it synthesizes normal RTL to a generic gates, that is genus generic library is there. So with that library it will synthesize. But here you can see with no increment and mapped switches added to synthesize, it actually synthesizes to gate level netlist with a given technology library. Suppose you are giving SCL 180 nanometer technology library, EMC 180 or TSMC 65, whichever technology library you are giving in the script file, it will synthesize the netlist file with that library without any optimization. Now after synthesizing, it will write one netlist file, that is intermediate.b. It will write one netlist file and also a do file for a conformal tool. So intermediate.b file will be the revised netlist, as we know that LEC requires two files, one is golden, another is revised. So here the intermediate.b file will be the revised netlist, and with this RTL and in revised netlist, it will form a do file for running the conformal tool. So this do file will use to compare the RTL to intermediate netlist. Okay, so here this is the optimized netlist, final netlist. Using incremental switch in the synthesize command, the gate level netlist will be given will be generated using the technology library with optimization. Suppose here if timing mismatch is there or any other faults are there, so that fault will be covered in these steps. And again after this, it will generate another new file, new netlist file, which is given noted by minus m, underscore m as a suffix to understand it, and an SDC file. So with this with this file and the intermediate file, it will form another do file, which is golden 1 and golden 2. Means golden 1 is this one, this intermediate versus optimized netlist. This do file will compare intermediate to final optimized netlist. So here you can see two do files are created. One is RTL versus intermediate, another is intermediate versus final. So in LEC we will fed these two do file one by one and check whether any anomalies are there or not. Okay, so this is the process of LEC and generating the do file. One more do file you can generate using RTL to optimize one optimized netlist. You can also generate another do file, that is RTL to final netlist. Here only RTL to intermediate and intermediate to final. So these two do files are shown here, but you can also generate RTL to final netlist. that is optimized one. So there will be 3 step of comparison. So you can add more comparison as according to your convenient. So let's move on to the tool and see how we can do all these steps. So open your Linux terminal and go to your work folder. Here these are my work folders. Under scene 1 I have saved the do file. So before going to the analysis or turn on the tool or invoke the tool, let us check the do file one by one. So this is one do file which is RTL to intermediate. So here is a command already written for conformal. This is your RTL Verilog code which is listed here and which is attributed as golden, elaborate design as golden, because we require 2 files in LEC. One is golden attribute file, another is revised attribute file. So elaborate this design as golden and read the Verilog top module is intermediate.b and named this as revised netlist. So these 2 files are marked here. One is revised, one is golden for comparison, and if any blocks are not identified, then report is as black box or latches that I have already told in my discussion, and then run the LEC, compare with the file with the golden and golden netlist. You can see here compare command is there, analyze compare command is there to compare the 2 netlist, that is 2 files. One is golden which is your original RTL file, another is revised which is intermediate.b. So this is the comparison between RTL to intermediate file. Another file is RTL to final. So here this is the RTL code as earlier, which will be the golden one, and your revised netlist is the optimized netlist generated during synthesis, which I have discussed in my previous slide during discussion. So this will be termed as revised and your golden will be the RTL. So same command, compare all points, all commands is there listed here. It will run one by one. So it is the ready-made command script for LEC do file. Next do file is golden to golden. My golden means intermediate to final. Sorry. So here no RTL listing is there. Only intermediate.b file as the golden, and the optimum netlist, that is optimized netlist, is the revised, and will compare both. So this is the commands of LEC and is listed in the do file. So let's open the conformal tool. CSH. I am pointing my script file. Command is LEC minus Excel. For graphical user interface, I am running this first in graphical user interface. It can be run in both DUIs, in command mode and in graphical interface mode. So this is the window of conformal tool, you can see. So we will initiate one by one file, do file. First RTL to G2 or RTL to G1 means the intermediate file. You can check one by one. Let's check it. So it is running now. Wait for some time. If anything problem is there, it will already it will show in the this window in either Here it will be shown. So depending upon your logic design, if very big logics are there, it will take time. So now done, compare is done. Here is the command LEC command window. You can now give extra commands if you want to. So let's check with other do file. We have till now checked RTL2 intermediate one. Next I am going to check RTL2 final do file. So it is now checking. %, completed. 13 non-equivalent points are there. Let us check. Wait for a while to get the command prompt free. So now command is free, command prompt is free. You can if there is some non-equivalences are there. So as I have told in the slides, permanent output, T flip-flop, black box is noted here, compare points, you can see. Now let's analyze this thing. What is the problem? Using a command analyze setup verbose. This is a command for analyzing the setup. Next command is analyze data path. So data path is analyzed. Next add compare. Points. Next compare again. It will compare again all the blocks. Now it is 100% completed. So if there is any problem arises, then you can run these commands. One is analyze setup verbose dash verbose, analyze data path, add compare points dash all as I have shown here, and compare finally. So this is the process of LEC in the GUI interface, the graphical user interface. Now I am showing you in command mode. So let's close it. So here you can give directly the command LEC minus XL or small XL, whatever you, nor GUI switch. Next direct do file you can specify. RTL, I am just showing you the final one. It is RTL2, the optimized netlist. So here it's running in the command mode. So as earlier in the graphical user interface, again it's showing some non-equivalency. So you can abort the command. Now use the command you write this again, this path analyze setup dash verbose. Next analyze data path. Next add compare points. Next compare command, final command is compare both the netlist. So now it's finally done. No error is there. You can see some equivalency already equivalent primary output flip flop but black box is shown here. So this is the total demo of LEC using Conformal tool. Now you can also check other do files also. So one by one, I have just shown you the one. It is RTL to final netlist. You can do RTL to intermediate, then intermediate to final. In this way you can also check. So this is it from the demo part. So this is all about Conformal tool demonstration. Hope you like this video. Please like and share my channel. Thank you.